welcome back to Fat Mama Physics. This is the second video that we will be talking about significant figures and how to deal with significant figures when you are adding, subtracting, multiplying, and dividing numbers with sig figs. Okay, so let's start with adding and subtracting, and then multiplying, dividing. Okay, the essence of these rules are the following. As a scientist, when you manipulate numbers, we can never be more confident than our least precise number. Okay, that's the idea. If you have a really precise number and a number that's not very precise, maybe you just know 2 digits, 2 sig figs, or even the 1 sig fig, you add them together, you can never be more confident than your least precise one. Okay, we can always be more uncertain. We can never be more certain. We want to be honest with our measurements. Okay, we don't want to communicate what we're unsure of. Okay, so that's the idea. That's the idea behind these rules. Okay, so let's start with adding and subtracting because they share very similar rules. What's the rule with adding and subtracting? Here we are, example 1. Let's take a look at number 1. So you notice that in number 1 there are 2 numbers with some decimal places. Whenever you add 2 numbers, you can never be more certain than the number with the least number of decimal spaces. Okay, so what do? You look at these 2 numbers, 9.99, 0.0223. You look at which one has the least number of place values. You go with that one, and whatever answer that you get, you round up to that last place value in the number that you just chose. I chose 9.99 because it only has 2 decimal places after the decimal. So my final answer, I'm going to round up to that last 9 that is in the number I chose. So I'm going to take the 2, I'm going to try to round the 1. The 2 does not round the 1 up. And if you're wondering what are the rounding rules, there might be some variation, but for us, we're going to say that anything 5 or higher is going to round up, 4 or lower is going to round down. Okay, simple as that. So this means 2 is not going to round the 1 up. We are just left with 10.01. Okay. Let's do a subtraction example. So here we have example 2. Again, choose the number with the least number of place values with after the decimal if there is. And that one is just the 15, okay, not the 0.7. So my final answer, I'm going to round to that place value in the 15, which is the 1's place. So that means that 4 is going to stay as 4 because 3 does not round the 4 up. That number stays as 14. So for adding and subtracting, we care about the place value. Now for multiplying, dividing is going to be a little different. Whenever you're dealing with multiplying, dividing, you are counting the number with the least number of significant figures. So for example, number 1, let's say we take 28.11 times 12. We look at the number that has the least number of significant figures. That is the 12. There is only 2 significant figures. So we calculate our final answer, which is 337.32. We round that to 2 significant figures because we can never be more confident than our least precise number that we started with, which is 2 sig figs. So rounding 337.32 to 2 sig figs, we are going to start off with, of course, the largest place value and work our way down, right? So we start with a 3 in the 300 and then the 3 in the tens place, and then we stop. So this could be 330, but wait a second. The 7 in the 1's place is going to round the 3 up to a 4. So that's going to give us 340 for our number right there. Okay, so that's how you do with multiplication and dividing. Okay, let's do the next one together. 9.8 divided by 0.787. Okay, so we look at the number with the least number of sig figs, which is the 9.8 2 sig figs. We calculate our answer, and we want to round this number to 2 significant figures, starting with the largest place value, which is the 10s and the 2s. We keep those, and then we see if the 4 is able to round the 2 up, and it doesn't, so this answer stays as 12. Can never be more confident than our least precise number. So notice, multiplication, dividing, we dealt with the number of significant figures. Adding and subtracting, we dealt with place value. In general, whenever we do physics problems, you will be expected to write your answer in proper sig figs, just like I expect you to write units for all your numbers as well, okay? So with most of your problems, you'll be mostly dealing with multiplying and dividing. There's sometimes you do adding and subtracting. Generally, whenever I do a physics problem, I look at the number of sig figs in the question. If there is 2 or 3, 2, and if I've used that number, I will round my answer to 2 sig figs, or 3, whatever that is. Usually I just count the number of sig figs, because we're mostly dealing with multiplying, dividing anyways. Now for some more examples, okay? Some mixed examples where we're kind of dealing with different ones. So let's do a bit of practice. I will do 1 and 2. You do 3 and 4, okay? So 1, I'm just going to write the number out first. I'm going to write the answer, okay? That could be your first step. If you have no idea what to do with the rounding, at least write the answer down. It means something rather than nothing, okay? So let's just do that. And I get this one, 0.005165. Okay, and I'm probably going to have less sig figs than that. 6.5, okay? And I'm going to write units in a second. Good point. So let's just double check. We're multiplying, dividing, meaning we're going to look at number of significant figures. So if we take a look, which one has the least number of significant figures? This has 3, this one has 2. So I'm going to round this answer to 2 significant figures. Keep looking at my place value. The highest ones are the 5 and the 1, which means I'm going to take the 6 and round the 1 up to a 2, leaving my answer in 0.0052. Don't forget units. Remember, I want houses, not apples, right? Joking. And also, I did mention, I don't think I mentioned, but I'm going to mention it right now. If you forget your units, that's going to cost you marks, okay? So that's how important units are in the scientific world, and we just talked about the importance of that earlier. Okay, so there we go. That's our first answer. Let's do number 2. Hey, remember we need to know our bed mass from math, okay? So brackets are first here. We're going to do this addition. So here we got 25, and we're going to add 1.05 here. These are in kilograms. So our final answer is also going to be in kilograms, because if you add apples to apples, you're only going to get more apples. We get 5062. I'm writing it backwards. So in this example, we need to round using the adding and the subtracting way with the rules here. So that is the least number of place values after the decimal place, which is a 25. I'm going to need to round to the ones place. So that's just going to be 26. So this 26.05 is going to give me 2 significant figures. So I have to write this next step here. That's going to be 26. And I'm going to write the 05 kilograms. The reason why I'm doing that is whenever you're doing any problem, you always don't round your numbers for significant purposes, figure purposes, until the very last step. The reason why I was doing this, I wanted to check how many significant figures I need to account for in my 26.205. So technically here I have 2 sig figs equivalent. And the 2.00000 meters per second, that is 4. So when I multiply the 2 numbers late in the next step, I am going to need to round my answer to the nearest 2 significant figures. So in my calculator, I have 26.05. I'm still keeping the number 26.05. I just need to remember that's two significant figures equivalent. And I'm going to multiply that by the 2. That's going to give me 52.1, and round it up to two significant figures. That is just 52. Okay, 1 does not round the 2 up. So that's going to give me 52. And the units, I have kilograms. I multiply by the meters per second. So that's my unit there. Okay, that's my final answer. Just a quick recap. When I did do the adding and the subtracting, I didn't actually get rid of all of my other digits. I only accounted for the number of sig figs I would have had, so that when I do a division or a multiplication step, I know exactly how many significant figures I have and what I need to round to in the end. Okay? The rounding doesn't happen in your answer until the very last step. Please don't forget that. Okay? So, I know it's a little bit confusing, but over practice and time, hopefully we'll get better. Okay? 3 and 4 are yours, so please pause the video and I'll come back in a second. Okay, so let's go over 3 and 4. So let's start with dividing first before subtracting. So again, we're going to round our answer at the very last step. Starting with 50 divided by 2, we get 25 kilometers per hour. And I'm going to have to subtract 12.0 kilometers per hour later. Now, okay, let's worry about sig figs in the first step. We are dividing, so we count the number of significant figures that carry over. 2.0 is 2, 50 is only 1. Ouch! So our 25 kilometers per hour only has one sig fig, okay? And that's the tens place. So really, we should round, if that were the final answer, we round it to 30. But we're not, because we're not done yet, okay? So when we now subtract the 12, sure, we do it normally how we would. So that's going to give us 13, for example. But now we know that 25 is only significant to the one sig fig, which is the tens place, meaning that when we round, we can never be more sure than our less precise number, which is 25. We're not really sure if 25 is 25, or is it 30, or whatnot. So we need to round 13 to the nearest tens place, because that's the place that we care about. We know that's that we are sure of. So 3 is going to try to round the 1 up or down. It's going to round it down. So this is going to go back down to 10. Just 10. Okay, that's our final answer. 10, our units, kilometers per hour. Okay, so that might have been a little confusing. Okay, hopefully, but the principle stands. You can never be more sure than your less precise number. The other principle to work off is making sure you round your final answer only at the very last step. Okay, so, okay, hopefully we don't need to have to deal with these really weird ones. And when we deal with physics, most of the time we're multiplying, dividing anyways. So that won't be too much of an issue. Last but not least, number 4, we have just multiplying and dividing. That's very easy because you just look at whichever number has the least number of significant figures. If you say that 6 over there with 1 sig fig, you are correct. So let's do that. If you're curious, this number here is the Newton's universal gravitational constant. This one's the mass of the Earth, and that is probably roughly the radius of the Earth. We'll learn that stuff later. Sorry, went on a tangent. Okay, so let's do some math. Okay, so put this in our calculator first. And our answer comes to 664,776. Rounding it to one significant figure, that's going to have to be a 7. And I'm going to show that using scientific notation, just like what it did in the problem. And that is 1, 2, 3, 4, 5 zeros. So 7 times 10 to the power of 5. There are no units I have to worry about. Well, technically it should be units. Anyways, there it is. That's our final answer. Okay, so there we go. That is adding and subtracting, multiplying, dividing with significant figures. Okay, so hopefully you'll get used to it over time. And hopefully that you'll be able to apply this to your practices and problems. I wish you good luck. Thank you for watching this video. Fat Mama Physics signing out.